Hey guys, and this week's video is going to be all about concavity. So maximum points, minimum points, what it means to be concave up, what it means to be concave down, and how you actually test whether you have a maximum or a minimum point. So let's get straight into it. So if we look at a function, we have quite a few of different points, but today we'll be focusing on two main stationary points, which are the maximum or the minima. So if you look at this function right here that I have drawn, you can clearly see that there's this point right here and this point right here that are they stand out. And that's because this is a maximum point and this is a minimum point, right? We can all see that. And this video is going to be all about how you determine whether a point is maximum or minimum and what it means to be a maximum or minimum point. So let's look at the shape of the maximum point. It goes like this little U that's facing down. So what we say about a maximum point is that a maximum point is always concave down. Now a minimum point is the opposite. We're kind of opening up. And so minimum point is concave up. And it might seem a little bit weird because maximum is down but minimum is up, but just always actually visualize the concave up or the concave down and you'll never get confused. Now, what else can we say about these points? And a hint, we'll be looking at the derivatives. Well, we can see that here, at first our function is increasing and then it's decreasing, and then here, first our function is decreasing and then increasing. And so if you think about it, if we go from positive slopes to negative slopes, in the middle, there must be a slope where it's 0. So we know that f prime of x at a maximum point is equal to 0. Similarly, we can apply that same logic to the minimum. If we are decreasing in slope but then increasing back, there must be a point where we go through 0. So a generalized statement that we can make is that f prime of x is equal to 0 in both minimum and maximum points. However, because that is the case, we cannot use this equation of f prime is equal to 0 in order to make sure that we have a maximum or minimum, because we can never differentiate between the two. And here is where we look towards the second derivative. And just as a reminder, the second derivative, so f prime prime of x, is the rate of change of the first derivative, so the rate of change of the slope. And if we look at the maximum point, what can we say about the rate of change of the slope? Where you can see that here we're decreasing in steepness, and in fact, we're going into the negatives. So over here, as you can see, the slope is decreasing. So what we can say about the second derivative is that it's going to be less than 0 for a maximum point. Now for a minimum point, we are actually going from negatives to less steep negatives to 0 to positives. So our slope is actually, if you look here, it's increasing and becoming positive. So our second derivative is going to be greater than 0 because, again, our slope is increasing in this case. And again, while it might seem a bit counterintuitive that for a maximum something is less than 0, but for a minimum something is bigger than 0, because these two concepts kind of just clash, just always imagine these concave up and concave down shapes in your head and imagine whether the slope is decreasing like it does in the maximum point or whether it's increasing like it does in the minimum point. Because in the maximum point, you always have to come back down, so you're going to have a decreasing slope, but in the minimum, you're always going to have to come back up, which is why you're going to have a increasing slope. So let's look at an example and really solidify our knowledge. So here I have a function, and f of x is equal to x cubed minus 3x squared plus 1, and I invite you to pause the video and find the coordinates of the minimum and maximum points without looking at the diagram, but you can use it as an aid if you feel like you've gone astray. So I hope you've done that, and now let's solve it together. So at first, we find our first derivative, which is just using power rules, is going to be equal to 3x squared minus 6x. Now, you can either go ahead from here and find the critical points. The critical points are the minimum and the maximum points, by the way. And I'm just going to note that down right here because it might be important to you. And they're critical points because the derivative is equal to 0. Or you can, like me, write the second derivative down right away. So let's firstly solve the equation of f prime of x is equal to 0. We can divide all of that by 3, so x squared minus 2x is equal to 0, and then 0 is equal to x times x minus 2. And solving this, we see that x is either equal to 0 or x is equal to 2. And this is exactly what we see on this graph right here. At 0, there's a maximum or minimum point, and at 2, there's a maximum or minimum point. Now, I know that you can see from this graph whether one is maximum or minimum, but I encourage you to just do the second derivative test. So the second derivative of 0 is negative 6. So what does this tell us? Our second derivative is less than 0, so it's a maximum point, which is exactly what we see right here. And again, that's because our slope is decreasing. Now, the second derivative of 2 is 12 minus 6, so it's 6. So our second derivative is greater than 0, and therefore we have a minimum point. And this is exactly what we see right here. At x is equal to 2, we have a minimum point with a derivative of 0 and a second derivative of greater than 0. So I hope this video was good for you to get an introduction into what concavity is, what it means to be concave up, concave down, and what maximum and minimum points mean and what are their characteristics in terms of derivatives. So I hope you enjoyed. Always keep this visualization aid in mind, and see you next week.